Hello, my name is Rodrigo Silva. I'm with
Maximiliano Sanchez.
I'm Harry Siegel.
and we're going to talk about the 2016 Dodge Challenger AC unit. We'll start with the functionality of the system. The system works with a refrigeration cycle. It is composed mainly of an expansion valve, an evaporator, a compressor, a condenser, and a receiver drive. How it works is that it basically, whenever the fans introduce the airflow into the system, it goes to the evaporator. The evaporator, what it does is it makes sure that the air is hot enough and it starts releasing some of the cold energy towards the system. If the user inputs a cooler into the system. If not, it's going to the compressor, where it applies some energy into the fluid, and then into the condenser, where in the condenser, with the refrigeration valve, it changes into a liquid, the refrigerant. And then after that, it's placed into a receiver dryer. And this one basically monitors the humidity, depending on whatever the conditions are set up for the inside. So the fans are the ones in charge, basically, of determining if the evaporator is going to be introducing cooler into the system or the condenser is going to be introducing hot air into the system. Then the main components that we have on this system is the heater core, the evaporator, the motor blower, the expansion valve, the AC actuator, and the housing distribution set. Harry is going to start talking about the first two components.
So the heater core, it provides heating to the main cabin of the car, and it does this by circulating the motor coolant from the engine block through itself, the heatsink design, and air is blown through it, and that air heats up through the heatsink and warms up the cabin. It has a complex and seamless design, and to achieve this, it has to use multiple sub-parts that need to be seamlessly put together. So the evaporator is extremely similar in construction, almost exactly the same, due to the fact that it needs to be an efficient heatsink. And so it, however, provides cooling for the cabin, and it does this by circulating the AC coolant. And it also has that complex design. Next up is Maximiliano Sanchez.
Okay, here we have the AC actuator and housing distribution set. The AC actuator is basically the one that regulates the temperature and airflow distribution. They work basically as a unit, but this one is like the brain, you could say, because it's the one that determines and commands what is it that the housing distribution set is going to do. The housing distribution set, on the other hand, is the one that redirects the flow by the use of valves, pipes, and different systems that it has on the inside. It also monitors the velocity, so depending on what is the intensity of the flow that the user is inputting into the system, the expansion valve, the housing distribution set is going to modify its physical parameters in respect to it. Next is going to be Max talking about the last two components.
Hello. We're going to be covering the motor blower and the expansion valve in their function. For the motor blower, it provides airflow throughout the cabin. You can manipulate the amount of airflow and the heat or cold setting within the cabin, and that's really what the motor blower fan is responsible for. Passing air through either the heater core if you want hot air, or through the evaporator if you want cold air. This is done because of the expansion valve. What the expansion valve is responsible for is aerosolizing the refrigerant from a high pressure tube to a low pressure tube. And that refrigerant is what's going to be blown, basically. And that's the function of the motor blower and the expansion valve. So next, we're going to be with Harry.
So we're required to choose 3 materials from our parts. And so we have 6060 T6 aluminum, which is a silver soft metal. It's very easy to machine, bend, and forge, which is why it's used a lot in industrial applications. It's highly thermal conductive, and it's very low density, so it's used in a lot of heat sinks. Grade 50 galvanized steel, it's steel coated zinc, so it has a matte silver finish. It is rolled and cut with ease, and it has a high strength and corrosive resistance, which is why it's used in a lot of fasteners to prevent rusting. Peroxide cured EPDM, it's a black synthetic rubber, it's molded into its final shape. It has a very high insulative ability, and it makes very good seals. So it's used in as a lot of O-ring material. Next up is Rodrigo Silva.
Okay, here, the components that I'm talking about for the AC and the actuator and the housing distribution set is the aluminum brass, which is mainly used because of its corrosion resistant, it's easily machined. It also has good strength and thermal and electrical conductivity. It's a soft metal and it's low cost compared to the pure aluminum, so that's the main reason why it's widely used in the systems. We also have the polyethylene terephthalate, which it has good strength to weight ratio. It's chemical and water resistant, which is appropriately really important because whenever the car is running, we want to make sure that the water isn't going to affect the electrical components of the system. So it is a really useful property for the AC actuator. It also has a low cost. The polyvinyl chloride is the last one, but it has good rigid and flexible interchangeable properties. So depending on what is the system that is requiring, especially for the gears, this material is really used. It's low cost and it's really abundant. Next is going to be Max talking about the last two components.
Hello. We will be covering over Type 303 stainless steel, copper, and nitrile rubber. The reasons why I chose stainless steel, specifically this type, is because it's very corrosive and it's corrosively resistant, my bad. And it's used for its improved machinability compared to Type 304 stainless steel or any other stainless steel. This is the one, this is the way to go. Copper Type L is used for the AC plumbing. It's mostly used for its conductivity and for its ductility. It can easily be switched out and easily machined to whatever size tubing that is needed. And finally, it will be nitrile rubber. This is mostly used for the plastic parts of the system, more like O-rings. These are really good for sealants in between tubing and whatnot. So next we will have Harry come up and present the production analysis.
The production analysis for the heater core and evaporator. Both are made from tubing and fins that are constructed by rolling sheet metal, sheet aluminum specifically. Then these fins and tubes are placed in a jig and they are soldered together and the tubes are soldered shut. Then the headers, which are made from stamped aluminum sheet, are pressed onto them and they are soldered along with it. Then external piping is added through fasteners. Since the evaporator is almost identical to this process, it is manufactured the same way. Alternatives are injection molding, which would need a complex, expensive setup. Next up is Rodrigo Silva.
The production analysis for the AC actuator and the housing distribution set is basically, on the AC actuator we have the housing and the gears, which is made by injection molding. We also have another component that is the chip, that is made for photochemical etching. This is really important because it's the one that transfers power to the system and also commands whatever it is supposed to do. We have the housing distribution set, which is the housing, the valves, and other internal components like piping, for example, which is done also by injection molding. For the housing and gears, the housing needs a nut press, which is an extra step that we put into the system for it to be able to properly assemble, and also the hot stamp that is basically going to put into the housing wherever the conditions and wherever the specifications that the technicians need to know for them to be able to manipulate the system properly whenever they need to be changed. Next is going to be Max talking about the last two components.
Hello. Up next, we'll be covering over the motor blower and expansion valve and how they are produced. The motor blower is mainly just three parts: the aluminum casing around the actual motor itself that can be made through extrusion, and the frame and the fan are both made of plastic. They can be made via injection molding because they are complex 3D shapes. And for the expansion valve, there's about four main pieces involved in the assembly of this component. It's the valve itself. It's a complex 3D shape, so die casting would be used to construct it. For the aluminum clamp associated with it, that would be extruded because it's a simple design. And the screws are formed through a process called cold heading. That's where metal is reshaped to a size that you need. In this case, it would be screws and fasteners. And the O-rings are made by injection molding because they're made out of plastic. So we will be covering over the manufacturing plant. Here you can see that this is the heating core. up next, we'll have Harry show you.
So the heater core, the manufacturing plan is almost exactly the same, just rolling through it. And it's the same as described in the the production analysis. So this is the heater core. This is the evaporator, and this is the AC actuator. And this is the housing distribution set. This is the motor blower fan. This is the expansion valve. And we're right back to the sustainability. So the heater core, its materials are widely available. They're manufactured in China, then are shipped to Canada where they're assembled. The aluminum and lead used as the main material and the solder are both toxic, so if disposed of improperly, it will leach into the environment and harm it. The evaporator has the same risks and is manufactured exactly the same way due to the similar construction. Up next is Rodrigo Silva.
Okay, here on the AC actuator and housing distribution set, I want to talk about a little bit about the manufacturing. So we want to actually start designing a value stream map to include the scrap on these productions, promote a culture to separate scrap materials. So for example, the plastics, the metals, the screws, all of that we want to be able to create a culture inside of the manufacturing plant. Also, whenever it's going to the customers, we want to inform them about responsible disposal because they're also an important factor for us to be able to design our system for sustainability. For the housing distribution set, and well, also for the plastics that are going into the actuator, we want to pursue alternate technologies to reuse the material. For example, we want to set up a grinder to recycle plastics. So whenever, like, for example, the scrap that is coming from the machines or on operations, let's say, like, for example, the nut press had an issue on one of the parts and needs to be, like, scrap. So we want to be able to not just scrap these materials and throw it to another company for them to process it. We want to be able to use a grinder to be able to recycle them, put it on our resin pellets once again, and put it into the machines for them to be able to reuse this material properly. Next is going to be Max.
Lastly, we will have the sustainability of the motor blower and expansion valve. Much like the points that Harry and Rodrigo covered before, any improper disposal of these components can harm the environment. The good thing about the motor blower and the expansion valve is that they're made out of parts that can be interchangeable with many other pieces from other assemblies and other cars and whatnot. They're both economic and reliable and mass-produced. So much like the case that Rodrigo said, that recycling these parts, as you see in this image over here, it would be essential to benefiting the environment and the overall economy. So this should wrap up our presentation. Thank you so much for listening and watching, and we'll have our references. Here you go. You have a nice day.